Welcome. In this tutorial I would like to show you now how to generate a grid of elements. As you have, if you see displayed, that's the basis of a cable net or a grid shell, something like that. And just to convince you that these are really individual elements and nodes. Let's go into create here, the create mode, nodes. And I just pick a node here, for instance this, and I move it around so you can really see, yeah, these are individual nodes. And from node to node, there we have, yeah, elements, as you see, with a distance of 2, yeah, the grid distance, and the overall size of this square would be 8 by 8. But now I will just start from scratch, just to show you what to do step by step. So we start to create our problem. Yeah, we have to adapt the display range, you know that already. Yeah, so I take out the box of side length 12 symmetrically from -6 to +6. Of course that depends on your problem, what you type in here. The grid spacing by 1 is always a good choice. Well, then we start here at the XY view at x to -4, 5, y to -4, just to generate one element of the length of our square. That would be 8 here. You know that already. We have to type in some initial values for the stiffnesses just to initiate the procedure. That is okay. And now I just copy this element in the different spaces or spacing of 2 vertically downward. We can do that also with Control C and Control V, and that's what I will do now. I just copy that. You see the reference point, and then we go to with Control V to the next instance. We would like to have a copy of this element of length 8, yeah, so I just have generated 5 of them. That means the height is exactly also 8. So if we just compare this with the y here of the -4 at the top here and y equal to 4 on the bottom. Yeah, so that would be one layer of, yeah, large elements, yeah, in one direction. So, and I just generate a second layer orthogonal to that in in the following. I just copy all of them. I'll just select all of them, then again we copy and paste that somewhere else, for instance here. So, and then I will rotate that by 90 degrees. I rotate it by 90 degrees or -90 degrees as you like. Okay, so that is okay. And now we just shift it on top, let's say, of the first layer, and you see we have now an orthogonal grid of elements. However, yeah, they are just not intersecting here, but each of these elements are spanning 8 meters, or what you say, the distances of 8. So what we have to do next is just to blend these two layers, just to identify the crossing points and just generating really a dense mesh of elements. That is very simple to do. We just select again everything, and now we go on any of these elements which are selected. We push the right button to receive the scroll down menu for the element, and then we just go to blend. And we are just blending all of these elements, and now we're already finished, and we just have arrived where we would like to see to be. You see everywhere we have now intermediate nodes here. Wonderful. And indeed, I just select this here. Now let's select this here. We just move these two, and you see really these are independent elements and nodes. Everything is fine. It remains that we perhaps give these elements further properties. Yeah, for instance, I select all of them again, and we just edit those. And if we just go into the basic element 3, grid element 3, 3, we see it by these hinges here. That would be now a grid of truss elements. Wonderful, isn't it? Perfect. Finally, I would like to show you how we can generate a hyper of grid shells or cable nets as the basis for form finding by blending operations. So you see I have already prepared what we need for that. So first of all, you see here the basic frames, the edge frame of our hyper. The ground view would again be a square of side length 8 here. for this example. And I also have prepared 2 layers of straight elements in Y and X direction, which I will blend layer by layer onto the respective lower layer. So starting with the intermediate layer, blending means projecting that into a certain projection direction onto the lower layer. So here you see we would like to project into the Z direction. And this projection direction is relative with defined with respect to the views. So in the XY view, the normal is the Z direction, that will be the projection direction. XZ view, the normal is the Y axis, which is here the projection direction for blending. And if we do blending in the YZ view, then the projection direction will be the X direction. So, in our case, I would like to first of all blend the intermediate layer of straight elements onto the edge frame of our hyper. We have to do that in the XY view, because here the normal is exactly the projection direction what we need. Okay, let's start. So I select the intermediate layer and the edge frame of our hyper. Then I go with the mouse into the XY view, go with the cursor on one of the selected elements here, press the right button of my mouse to receive the drop-down menu, and then we go to blend, and schwuppdich, you see that we now have blended this intermediate layer onto the edge frame of our hyper. Looks nice, does it? And now it's almost straightforward what we have to do next. So we take the remaining layer of straight elements, select it with everything what is below. Again, we go into the XY view because we would like to blend into the Z direction, and do the blending operation. And here it is. And whoop! So we have received a nice hyper frame, with straight elements, which are the nodes are on a hyper surface as we think it should be defined. And just to convince you that these are really intersecting nodes and elements, I just pick one of these. And I must just move it around. You see these are not all small elements, just crossing at these points, nodes which we just have generated to undo the last action. So we have we can repeat it, the blending. Here it is. So that are the blending operations. They are very helpful to generate quite sophisticated shapes. Thank you.